Okay, so hi everyone, Senan this side, and in this video we are going to see this combination sum problem. So the reason I'm doing this is because combination sum 2 is a LeetCode daily problem for today. So let's look at what combination sum is, so you are easily able to tackle the combination sum 2 question. So you are given an array of distinct integers candidates and a target integers as target. So what you need to do is return a list of all unique combinations of candidates where the chosen number sum to target. Fine. You may return the answer in any order and the same number may be chosen unlimited number of times. This is the most important part of this question. This is the line that this question wants to check, can you implement this or not. Okay, so the test cases are such that there are less than 150 combinations for the given input. Okay, let's look at some test cases. So the first one is 2 3 6 7. So and target is 7. So what I can do is basically I can take two 2's and one 3 to get 7, or I can just take a single 7, and that is all that is possible using this array and this target. Note the test cases are given to you in a sorted order, but that may not be the case. In case 2, you see 2 3 5 and the target is 8, so either you can return 3 5, either you can return 2 and 2 times 3, or you can return all 2's 4 times. In the last test case, you have a single element 2 which is greater than target, so you cannot achieve this target at any cost. So how do we do this? Basically we are going to use a brute force approach, and the solution would be of time complexity near about or more than exponential, and the logic is as this. So given this question, the candidates and target, we would declare this answer vector, which is what we are going to return, and we are going to have a temporary array so that we can keep track of the current possible solution that we have till now. Now we call this comsum, and that would basically solve our question. Now let's see what is this comsum and what is this doing. So combination sum takes an integer I, target, the candidates list passed by reference, the temporary list that stores the current solution, and this last one, the answer that is passed by reference as well. Now what this does is, given an integer I or the index I, this is basically the index of the candidates, what it checks is if this is a valid index, either I don't take the element present at the index I, or I take that element. That is the only two possible cases that we can come up with. Note the elements are unique, right? So we can do this. You'll appreciate the uniqueness of elements when you understand that we have to return unique answers. These elements should not be repeated. Anyways, now we'll discuss the base case later on. Let's see this. If we don't take this element, or we don't take this candidate I, that means my target would remain the same. As you can see here, target is same, but I move one step ahead. So I don't take this current candidate, I check what is the possible solution I can get without taking this element from the remaining array. Otherwise, if I have to take, what I need to check is the target is greater than equal to candidates, right? And this is because if you see the constraints, candidates are also positive as well as the target. So target would never go to a negative value. So we need to make sure that this value is always positive. And now what you see is, if target is greater than the candidates, this candidate I can be a possible increment to our solution, right? If that is the case, I take that as a part of my answer. That is the temp. Don't confuse this answer that I said with this answer. This is a vector answer, and this answer would be a part of this vector answer. Now what I do is, since I have taken this element, what would be my new target? My new target would be the target minus candidates of I, obviously. But since we did not take here, in this case we moved one step ahead. We did not move one step ahead in this case. Why? We did not move one step ahead because we can have unlimited number of times. Any element can occur unlimited number of times. So I can pick this element and I stay at this position as well, and I can again pick this element again. Now let's assume that we took this element, we got the solution somehow, and that is stored in this answer. Now after coming out of this combination sum function call, since we had changed the state of this temp, right? Now we need to revert back to the original state. So I remove that element back as well, and then I return. But now what is the base case, right? So the base case is, if I is equal to candidates dot size, that means I has the index that we are at has seen all the elements in the list, and now we are at the end of the list. That means there is no more element to see. Now if we check, have we reached the target or not? So that means the target should be 0 at this point of time. Think of this recursively, right? So we are calling this target for target minus candidates of I. So if you think recursively, if target is 0, that means all the elements that I have stored in my temp is actually a valid part of the answer. So what I do is I take this temp and push back into the answer array. Otherwise, if target is not 0, it's a positive value. So that means the given elements in our array is not summing up to our let's say not summing up to our target, so we return. So yeah, that was the whole video, but let's discuss the time and space complexity. Now at each and every element we are doing take or not take, take or not take. So that would give us a time complexity of 2 to the power n. But since in this case we are taking the element and still staying at the same position, so we can take multiple times, so the time complexity would not be 2 to the power n, something more than that, maybe something more than exponential, right? So we cannot actually exactly quantify that value, but it's at least more than 2 to the power n. So 2 to the power n is a lower limit of this lower end of this of the time complexity in this question. What can be the space complexity? Space complexity is the maximum number of elements that you can store in your temp, assuming that we are not taking in consideration the size of this answer, right? So what can be the worst time complexity in this? So that would be the minimum element target divided by the minimum element. So basically target by the minimum element in the candidates. So that is the maximum number of elements that you can actually push into the temp, right? So let's say if the target is 40 and our candidate of I is 1, I can take this element at least 40 times, right? And that is the worst possible case. So in that case I would just go to I. This would not be sufficed. This this if statement would never be true. What we would do is we would just go for I plus 1, I plus 1, I plus 1 till the time we reach the last element, one more than the last element of candidates, and at that point we just return. Either if target is 0, then we return it and we push that into our answer vector. Otherwise we just return back. So that is the whole video all about. Hope you enjoyed this, and uh, do share this video with someone you think this video might be useful to. And anyways, yeah, thanks for watching and bye.